Welcome to lesson 132 of algebraic concepts, or 2132 overall, factoring completely. So let's get into it. Here's our objective, our vocabulary, some rules and notes. So please pause the video and read through these things, look through the pictures, so you get a better understanding of what we're trying to do in this video. So what you look to factor, I cannot see any 4 does not go into 169, so there is no common factor. But what I do notice is that 169 is a perfect square. So if I take the square roots of 4x squared and the square root of 169, I get 2x and I get 13. And because this is a difference of squares, and I went over difference of squares in factoring trinomial special cases, I get 2x plus 13 and then 2x minus 13. So that is our that's our first example. So please look for things that can be factored, or if you don't see any things that can be factored, look for square roots, and that will help you break down the binomials, trinomials, or whatever polynomials you have sitting in front of you. Okay, so 16AT, what do they all have in common? They all have a 4a in common. So if I factor out of 4a, 16 divided by 4 leaves 4t squared minus 4t plus 1. Okay, so that would give me 16at squared. That would give me 16at. That would give me 4a. And then now I have to look for factors that make up this trinomial. So let's try 4a. No, a. What am I doing here? Sorry, y'all. 4t minus 1 and then t minus 1, because I have a negative here and a positive here. That lets me know I'm dealing with two negatives. So let's just do the work and see if this works out. Negative 4t minus 1t plus 1, that's negative 5t. That's not what I have. So this doesn't work. Okay, so I don't think this, you can go further than what we went. Let me try something else. Okay, that didn't work, so let's try something else. Let's see, is 4t squared? Oh, look, 4t squared is a perfect square. I still got the eraser on. Let's go back to the pen. 4t squared. Let's see. 4t is a perfect square, and 1 is a perfect square. So what is the square root of 4t? Is 2t. The square root of 1 is 1. Oh, look at this. 2t minus 1, because the sign here is still negative, and then 2t minus 1. Now, because we had the same term multiplied next to each other, so x times x equals x squared, I am going to rewrite this as 4a 2t minus 1 squared. And like I said, sometimes these things will not be evident easily. It won't be easy for you to see right away, and you're going to have to try different tactics to factor things completely. So that seemed to work and get us down to where we needed to be. And let's look at our third example. Okay, so we might have to use a little bit factoring by grouping here. Let's see, they all have an M and N in common, all of them. 3, 5, 12, and 20, all four of these do not have a common numerical factor, but let me pull out the MN and see what's left. So I'm left with 3m cubed minus 5m squared plus 12m minus 20. All right. M is in Mary for next to 12. And let's see what I can do here. What I'm going to do, like I did in a previous video, is I'm going to group the first two terms together and the last two terms together and see what I can pull out. So 3 and 5 do not have any common factors, so let's write M, N. Let's put a bracket. And then, so what can we pull out? We can pull out an M squared. So if I pull out an M squared, I have 3m minus 5 plus, what can I pull out of 12 and 20? 4. I can pull out a 4, and I will have 3m minus 20 divided by 4 is 5. Close the bracket. Oh, look at that. The 3m minus 5 is the same binomial term. So now I'm going to move some things around. Our m squared and our 4 can be grouped together. So the m and the n stay outside. And now I have two binomials, m squared plus 4 and then 3m minus 5 inside the brackets. So there you go. So those were our 3 examples. Let's see if do we have an example. No. So those were our 3 examples. Please work on the practice problems. And go to the first practice problem, write it down on a piece of paper, work through the problem, go to the next one, so on and so forth. And once you have tried all of the practice problems, I will meet you at the end of the video for a recap. Okay, so let's see. What can we pull out of here? 3y, and we'll be left with x to the 4th minus 81. Because 243 divided by 3 is 81. We pulled the y out was common, the 3 was common. Okay, so now this is a difference of squares. If you take the square root of x to the 4th and the square root of 81, you're left with x squared and 9. So you have 3y, x squared plus 9, x squared minus 9. I guess you can put these in brackets too. There you go. Problem 2. So, what factors of 12? 1 and 12. 3 and 4 add to 7. And 6, 2 and 6. Oh, 3 and 4 add to 7. Look at that. So, if I do x squared minus 3 and an x squared minus 4, that is our breakdown. And if you don't if this is not evident to see or easy to see, please go back to factoring trinomials. I did a couple videos ago. I can't remember the number, but that's what we get. So some of you are looking at me skeptically. Let me foil it out for you so that you can see what we have. We have x squared times x squared is x to the 4th. Outers minus 4x squared. Inners minus 3x squared. Last plus 12. And you can see that 4 and 3 add to negative 7x squared. So it works. There you go. And what is common? Three B, 2A. There's nothing in common. So the factors of 2 and A are 2 and A. So this is going to be a 3B plus 2A, and then let's try B minus 1. And let's see what we get. First, 3B squared. Outers, minus 3B. That doesn't work, people. Inners gives us 2AB. And last gives us a minus 2A. You know what? I don't think this is going to work. I think we're going to have to separate the 2 and the A, because we need 3AB and we have 2AB. So let us do this. And I'm going to pick a different color to work with. I don't like writing in yellow all the time. All right, so we know we got 3B. I think we're going to have to separate the A and the 2. So let's try plus 2. And then B minus A. And let's see what we get. First, 3B squared. 3B times B is 3B squared. Last is minus 3AB. Inners is plus 2B. And then last is minus 2A. That leaves us a negative 1. Right. This doesn't work. This doesn't work either. I know I did it right. First, 3B squared. Outers minus 3AB. Inners 2B. That doesn't work. Okay, so we're going to have to group and then see if we can separate. So let's group. Okay, so let's group this as, wouldn't need a pen. Let's take out a 3b. We're left with b minus a minus 2a. There's nothing in common. So this one, I don't see any solution for. So this is not factorable. And when you have something that is not factorable, which came up in the last video, we call this a prime polynomial. And prime means it has no factors. There are no common factors. You could have pulled that out, but again, there's nothing common with the 2a. So sometimes you just get things that don't work out. But we worked through all the steps. We tried things, and it didn't work. So this second step is only partially factored. That could work as a partial solution, but there's nothing common to both terms. So that's the end of our video. Thank you for watching this video. Please watch some of the other videos in this series, and I hope to see you on the next video.